All right, so we're referring back to those, right? Not this thing on the bottom. I was doing probability of the question. What I don't have on the board here is the amplitude of these original ones. The amplitude is the height of the graph, like the highest point minus the lowest point divided by 2. But really it's just the number in front of the equation, okay? So if there's no number in front of this equation, what could I put? A 1. So the amplitude of the original is just 1. So from -1 to +1 is 2 units, and then you cut that in half. That's what an amplitude is. So the peaks divided by 2. But when there's no number in front, then the amplitude is 1, all right? So I'm gonna take, for this first one, I'm gonna look at the sine original function. So because this is for sine, so I'm gonna look at this one up top here, and I'm gonna change it. I'm gonna change it because there's a vertical, either stretch or compress. That number in front is gonna make the vertical part of this change, which means the horizontal part doesn't change. So I'm gonna keep the x values in the table the same. Today, we're gonna do some horizontal changes, so these values will eventually change. But with just that number in front, the only thing that's changing is the vertical stuff. So I'm gonna keep that the same. It is a vertical stretch. You don't have to memorize that if you don't want to. Yesterday we talked about how you can put it in your calculator. So like in y1, I could put the original sine x, and in y2, I could put 4 sine x. You just want to make sure your calculator is in degree. I adjust my window to match this one. So the x min is 0, and the x max is 2 pi, and the scale is going up by pi over 2. All right, I can keep the -10 to 10 or not. These numbers are going to be smaller, so I'm going to do 5s. All right, so what you're going to see here, did I not change it to radian? No, I changed it to degree. All right, so what you'll see here in blue is the sine, and in red is 4 sine. So the red gets taller, and we call that a stretch. Okay, so you don't have to memorize that. You can see it in the calculator if you want. But if the number in front is greater than 1, it's going to be a stretch. And if the number in front is less than 1, it's a fraction, it's going to be a compress. So I would call this a vertical stretch by a factor of 4. You can just say a vertical stretch of 4. That's fine, okay? So what that does is it takes the original amplitude 1 and it multiplies that amplitude by 4. It makes it 4 times taller, so the new amplitude is 4. It takes all of the y values of the original sine, so the critical points of sine are 0, 1, 0, -1, 0, and it multiplies them by 4, making them 4 times taller. So it's 0, 4, 0, -4, 0 is the new table. You okay with that one? All right, the next one, there's this 1/2 in front. If you don't know how to do it, you could type them in your calculator. I'm not going to type them in the calculator, okay? But you could put cosine in y1 and 1/2 cosine in y2 and look at the graphs. You'll see that the new graph is shorter, okay? And that's called a vertical compress. You're going to have a compress when that number in front is less than 1. It's going to get 1/2 the size of the original. So if the original amplitude is 1, 1/2 of that is 1/2. I'm taking 1 and multiplying it by the number in front. All right. In terms of the table, it is a vertical change. Nothing horizontally is changing, which is my x-axis. So I'm going to keep these values the same as the original. What I'm going to change is the vertical values. The critical points of cosine are different than the ones of sine. The cosine starts at 1. 0, -1, 0, 1. The pattern is the same. It teeters and totters between the 1s and the 0s. It's just cosine starts at 1 and sine starts at 0, right? And I'm going to multiply all of these by 1/2. So 1 times 1/2, 0 times 1/2, -1 times 1/2, 0 times 1/2, 1 times 1/2 would be the table. Technically, you could do this unit without a calculator. You just don't have to. You okay with those two? All right, the difference between the next two, I think they have some reflections. So that negative in front is going to cause a reflection. The 2 is the stretch compressed number. So I would say it's reflected over x-axis. There's never a reflection over the y-axis. It only flips down and up, okay? So it's always reflected over the x-axis. The 2 is greater than 1. So that's going to cause a stretch, right? I'm looking at the negative does one thing, the 2 does something else. So this is a vertical stretch. I'm just going to say of 2. I don't have a lot of space there to put by a factor of 2, okay? What that means is the graph is going to get 2 times taller. So if the original height amplitude is 1, and I make it 2 times taller, well, 1 times 2 gives me an amplitude of 2. You don't call the amplitude -2. The negative is the reflection, it's not the height. Amplitude is the height, okay? No such thing as a negative height, so I'm going to call that amplitude 2, all right? We are changing the vertical stuff here. None of the horizontal, none of the our x values are going to change. What's going to change is the y values. This is a sine, so I want to go with the 0, 1, 0, -1, 0. And I'm going to multiply these by -2 across the board. Okay? I'm going to write that enough times, right? All of them are getting multiplied by -2. So 0, -2, 0, +2, 0. The negative does the reflection. And it's always over the x-axis. Now in this case, the number in front is a 1/5. That number is less than 1. Because it's less than 1, it will be a vertical compress. And that's of 1/5. Meaning it's going to be 1/5 of the original size. It's going to be shorter, all right? So I'm going to take the original size of 1 and multiply that by 1/5. So the new height is going to be 1/5. It's going to shrink. That's the compress. The x values don't change because this is only vertical. We're doing cosines. So the 1, 0, -1, 0, 1. And I'm going to multiply all of those by -1/5, the number in front. So -1/5, 0. +1/5, 0. -1/5 would be the new y values. Are you okay with those? That's a summary of yesterday. Today, we're going to do horizontal stretch compress. It's similar. The process is the same. We're going to multiply. But because it's horizontal, we're going to multiply the top numbers, which adds a layer of difficulty because the top numbers are fractions and also they have pi in them, all right? So the multiplication becomes a little harder, all right? Today we will do horizontal stretch compress and you'll learn this new word called period, right? So we have amplitude for all of these and then we'll have a period as well. So I'll explain to you what that means. So we'll do the examples in the toolkit today. I think we'll get back to the workbook or we might not. So just leave it out just in case. And go to toolkit page 4. We're looking at that same general function. A, sine, B, x minus c plus d, right? And we're cosine. Each letter does something different and each day we'll talk about a different letter. So yesterday we talked about A, and A is amplitude. amplitude causes vertical stretch and compress. Today we're going to talk about B, okay? B affects what's called the period. The period is how long it takes for the sine and cosine function to complete a full rotation. And by rotation, I mean how long does it take to get around the full circle, which we talked about yesterday. How long does it take to get through the 5 critical points, okay? So, the period of this function, the original, to get around the whole circle and get back to where I start, it takes 360 degrees, right? Which in radians is 2 pi. So to get through the whole rotation of the circle, it takes 2 pi radians. So the period of the original function is 2 pi. But that speed changes when you put something in B, the B spot, okay? The B is kind of like a slope. See how it's next to an X? So I want you to think about like y equals x, all right? So if I were to graph y equals x, let's say it looks something like this, all right? What if I were to graph y equals 3x? What happens to the graph? It gets steeper, right? And so if it gets steeper, the way that I think about that is it's increasing faster, right? So if it's increasing faster, it's going to finish the 360 quicker. Does that make sense? So this is a faster slope, which means I'm going to get through these values quicker than 2 pi. All right, so that's going to speed up the process. Whereas if I did something like this, that slows it down. I'm running at a slower rate. And if I'm running at a slower rate, I'm going to finish the race slower, right? So that's going to drag this out longer. You with me? All right, so if the number in front of my x is bigger than 1, it speeds up the process. And if the number in front of x is less than 1, it slows down the process, ultimately changing what's called the period, all right? So what we're going to do is instead of looking at it linearly, we're going to look at it with our trig functions, okay? So to find the period, the new period, we're always going to compare it back to the original. So that's the 2 pi. And then we will divide that by whatever the b value is. You're not going to have to memorize that. I'm going to show you how to get it in the table. But some of you like to memorize things and not like fully understand them. So if you're a memorizer, that formula works every time. But I'll show you how to do it without it. Right? So it's 2 pi over b. So what this value does is it makes the time that it takes for me to get around the circle longer or shorter. So it stretches it horizontally and shrinks it horizontally. That's like the time it takes to finish this. So we have a horizontal stretch and a horizontal compress. Horizontally is being changed. So since period is a horizontal change, it's going to impact the x values of the table. So we're going to change the top stuff. This is the part that gets tricky though, because with amplitude, if the number in front is like a 5, that is a vertical stretch. And if the number in front is like a 1/2, that is a vertical compress. The opposite happens here. If the number in front here, b, if that is a 5, it's not a stretch. If that's a 5, it makes the pace faster, which actually shrinks the graph because I'm getting through the curve in a quicker amount of time, okay? So a horizontal stretch is going to happen when the B value is between 0 and 1. You're gonna see a fraction there. So you might just wanna add, like if it's a fraction, it's gonna be a stretch, which is the opposite of the way it is for an amplitude. A fraction is a compress for amplitude, and it's a stretch for period. They work opposite, right? So a compress is going to be when the b value is greater than 1, because what's gonna happen is it's gonna speed up the process, which is actually gonna make the graph get skinnier. And the skinnier makes the period a little shorter. Hopefully it makes more sense when you see it visually in an example, alright? So let's just go into an example. These are the rules that you can memorize, but you don't have to memorize them, alright? Here we go. We've got sine of 3x. Remember, 3x makes the graph 3 times steeper. Right? Like if I'm running 1 mile per hour and somebody else is running 3 miles per hour, they are running faster than me. They are going to finish the race before me. So this table is going to go through a full rotation before the person running 1 mile per hour. All right? So there is a horizontal change here happening. And it is going faster and faster, which is going to take what once took 2 pi to finish the race, and it's going to shrink it. I'm going to run the race a little quicker. I'm going to finish it shorter. So this is called a horizontal compress, when the number here is bigger than 1. So I'm going to call this a horizontal compress. What once took me 1 to finish, or 2 pi to finish, is now going to take me less than that. How much less? 3 times less, all right? Anytime you have a compress, the number you're multiplying by should be a fraction, because the only way to make numbers smaller is to divide them. So I'm actually going to call this a horizontal compress of 1/3. In order to shrink something, you need to divide it. I'm not going to actually multiply by 3, because that's going to make everything 3 times bigger. I need to make it 3 times smaller, because it's quicker. So I'm going to multiply it by 1/3. Before we get into period and the table, let's just talk amplitude of this one. Amplitude is the A. It's the number in front. So if there's no number in front, what could I put? A 1. So the amplitude for this one is 1. That's like what we did yesterday. Everybody okay so far? Kind of. Maybe. All right. So if I only have a horizontal change here, there was no number in front that made a vertical change. I only have a horizontal change. That means the vertical change isn't going to be different than the original. So if this is a sine, then I'm just going to keep the y values of the original sine. I didn't stretch or compress this vertically. So I'm going to keep the 5 critical y values. 0, 1, 0, -1, 0. I'm not altering them. But I'm going to change the original x ones.
So for cosine, you would keep x?
For cosine, I would keep the y values as well. They would just be the different y values. Because it's horizontal, I'm only changing x.
Okay.
All right, so the original x values look like this. 0, pi over 2, pi, 3 pi over 2, and 2 pi. But I want to change them by a factor of 1/3 because I want to shrink them. And the reason I want to shrink them is because this is going to finish faster than 2 pi. If I multiply them all by 3, that means I'm going to end the race at 6 pi, which means the race is taking even longer, right? But this race shouldn't take longer because I'm running faster, right? So instead of multiplying by 3, I'm going to multiply by 1/3 or divide by 3, however you want to look at it, all right? So I am going to take each of these values and I'm going to multiply them by the reciprocal of that number. So 1/3. Alright, so here's what happens when I do that. 0 times 1/3 is still just 0. That one's pretty easy. When you multiply fractions, it's the top number times the top number and the bottom number times the bottom number. So this next one is going to be pi times 1 and 2 times 3. So it's pi over 6. When I'm doing this next one, it's not a fraction times a fraction, but couldn't I make this a fraction? What could I put it over? 1. So it's pi times 1 over 1 times 3. For the next one, when I multiply straight across, I get 3 pi, because 3 pi times 1, over 2 times 3, which is 6. But what do you know about 3/6? So I'm going to change this to pi over 2, because 3/6 is the same thing as 1/2. Pi over. Does that make sense why I switched that? We're just simplifying the fraction. All right, and then the next one, again, I can make this a fraction by putting it over 1, and it's 2 pi times 1 over 1 times 3. This makes things shorter. What once took 2 pi to get to the end, now takes less than 1. 2 pi over 3 is 0.67 pi, right? It's less than 1. So this is quicker, right? So one way to do it is to go through and do a little multiplication. Another way to do it was the formula. We said the period was 2 pi over b. B is the number in front of x, which is 3. So the period is 2 pi over 3. Or look, how long did it take to finish? 2 pi over 3. The period is, where does it end? Right, it ends at 2 pi over 3 now. 2 pi over the b value, which is 3. That's the end result. It's quicker because we finished it in less time. What's tricky about this is what is a vertical compress is different than what is a horizontal compress. A vertical compress is a fraction, but a horizontal compress is a whole number, and vice versa. All right, so let's look at the next one. It says cosine of 1/4 x. 1/4 x means this person, if we're running a race, is running 1/4 the pace of the original. This person's running slower than this one. So it's going to take longer to finish it. Right? If you're running slower, it takes longer to finish the race. So this last number should be a number bigger than 2 pi because it needs to be further out. We okay with that? All right, so since that 1/4 is there, it's going to take longer. So it's going to take what once started at 0 and ended at 2 pi, and it's going to make it start at 0 and end somewhere further out, which is going to stretch it. So this is called a horizontal stretch. And that idea is different than vertical. All right? And we would say your factor is the reciprocal. So it would be 4 over 1. So it would be by a factor of 4. If you want it to stretch, you need the multiplication number to be bigger than 1. So I need to take the reciprocal of that. Before we get started on the table, the amplitude comes from the letter A, and the letter A is the number in front. If there's no number in front, then the amplitude is 1. So there's no amplitude change here. There's no vertical change. So the vertical values, which are the y values, are not going to change from the original. And this is a cosine. So I'm going to look at the cosine ones. So the original cosine values are still consistent. Once we start to put a number in front as well, that's going to change too. So sometimes we're going to be changing x and y values. All right? So this is a horizontal stretch, and horizontal is x. So I'm going to focus on the original x values. Right, those are the original x values that got me around the circle. But now I want to expand them. I want to make them 4 times bigger. So I'm going to multiply all of these by 4. some of that multiplication is pretty straightforward. 0 times 4 is 0. Pi times 4 is 4 pi. 2 pi times 4 is 8 pi, because 2 times 4 is 8. When you're doing the fractions, you can change that 4 to a fraction by putting it over 1. And then just do the top times the top, bottom times bottom. So 4 times pi is 4 pi, and 2 times 1 is 2. Well, what's 4 pi over 2? 2 pi. So I can change that to a 2 pi. And if you're observant, you can figure out what the next one is without even doing the math.
6 pi.
Right? It's 2, 4, something, 8, then it's gotta be 6. But if you're doing the math, 3 times 4 is 12 pi, over 2 times 1 is 2, and 12 divided by 2 is 6. So that's where the 6 pi is coming from. The period is how long it takes to finish all the 5 critical points. From start to finish, now it took me 8 pi to get there, which is longer. That's what's stretching it. And it's stretching because the 1/4 is making the pace slower. All right? So the new period is 8 pi. That's where I finished the table. If you want to use the formula is 2 pi over b. B is, for this one, 1/4. So it's 2 pi over 1/4. To do division of fractions, it's keep, change, flip. So it becomes 2 pi times 4. Just like we did to all the values in the table. That's where the 8 is coming from, if you want to use the formula. Otherwise, just look at the table and see where you finish up. Alright, we've got one more that I wanted to do with you. Because this one's got a few things happening. So I'm looking at example 8. I think I skipped one. Alright, so I've got the negative in front. Does anybody remember what the negative in front does?
Reflex.
There's a reflection. So there's a reflection over x-axis. The A value is 6. Stretch or compress. Vertical, because it's in front. Is that a vertical stretch or compress?
Stretch.
It is. If you don't know that though, you can always mess with your calculator and say, okay, well, what does sine x look like versus what does 6 sine x look like? Ignore the negative. Like, look at that piece. Right? That piece is the 6. I think my window isn't high enough, so I'm going to change it. Right? So the blue is the original and the red is the 6. It's stretched. It's taller. Okay? So that's the stretch. We call that vertical because it's up and down. So there's a vertical stretch, and anytime you have a stretch, your by number should be a number bigger than 1. So it's getting 6 times taller. Everybody okay with that part? And again, you can use your calculator for the next part too. If you want to focus in on the 2, right? Do it's pushed it in, it's made it faster, right? Like that curve is going at a quicker rate. It's taking this big curve and pushing it into here. So that's a compress. The 2 does a compress, which is opposite of what the 6 does. So that's kind of confusing, all right? So we call this a horizontal compress. And anytime you have a compress, then your by number should be a fraction. So I'm not going to say a horizontal compress of 2. That's redundant. Okay, so it's going to be a horizontal compress of the reciprocal of 2, which is 1/2. All right, so we'll call this a horizontal compress of 1/2. Stretches have whole numbers, compresses have fractions. So my amplitude is my A,
6.
which is 6, not -6. The negative is the reflection. So the height of the graph is 6. My amplitude we'll figure out. We could use the formula, 2 pi over b, but we're not going to. We're going to figure it out from the table, right? So let's do the y values first, all right? So this is sine. So I'm going to use the original y values of sine, 0, 1, 0, negative 1, 0. But now it's negative 6 sine. So it's taking all of those values and multiplying them by negative 6. The reflection impacts the y values because a reflection takes me from here to here, which is a y shift. That's vertical. So that's where the negative's coming from. And the 6 stretches it vertically, which is y values as well. So I'm multiplying them all by negative 6. By 1/2, yup. So I'm going to take the original x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I want them to shrink. In order to make them shrink, I would need to multiply them by a fraction. Because multiplying them by 2 is going to make the numbers get bigger. I want them to get smaller. So I'm going to do times the reciprocal of that 2, which is 1/2. If it's not a fraction, you can make it 1 by putting it over 1. So pi over 2 times 1/2. Pi times 1 is pi, and 2 times 2 is 4. Pi times 1 is pi, and 1 times 2 is 2. 3 pi times 1 is 3 pi, and 2 times 2 is 4. 2 pi times 1 is 2 pi, 1 times 2 is 2. What happens there? 2 pi over 2. That's just pi. The 2's cancel out. So what once took me 2 pi to get completely through, now only takes me pi, which is half the time of the original, right? 2x doubles the speed, which means I finish it in half the time. That's why this is pi rather than 2 pi. It's cutting everything in half. Alright? So I think that what's confusing is this is a stretch and it's a number bigger than 1, but this is a compress and it's a number bigger than 1. So you have to understand the idea of speeding up an x value actually shrinks it. Alright? So I'm going to have you try the other toolkit. Alright, it's example 9. And I just kind of put some notes up here that I think might help you if you need it. So the A value is going to affect the vertical stretch and compress, which is the Y values. So that A value will change the Y values of the table. The B value affects the horizontal stretch and compress, which is X values. So you're going to change the X values of the table. This one's a little trickier because a stretch for B looks different than a stretch for A, so just keep that in mind, all right? Take a few minutes, try it, and then I'll go over this one. What's the 1/4 do? Is that a vertical stretch or a vertical compress? If you don't know, you do this. Cos of x, 1/4 cos of x, and compare them. Is the red shorter or taller? Is the red shorter or taller than the blue? You can look at the starting point. See how the red's lower? Okay, so this is called a compress, alright? So in terms of vertical, I call it a vertical compress. And anytime you have a compress, the of value should be a fraction. So I'm gonna keep it as 1/4. What does that mean for my y values? What should I do to all my y values? Multiply by 1/4. So I get 1/4, 0, negative 1/4, 0, 1/4. It used to be 1, now it's 1/4, it's shorter. Okay, that's the compress. Alright? What about 1/2 x? Think about that slope. The slope is slower, so the speed is slower. What's that going to do to the graph? Makes it bigger. It's a stretch. Alright, so this is a horizontal stretch. And anytime you have a stretch, your of value needs to be bigger than 1. That's what's going to make it stretch. So I'm going to take that 1/2 and I'm going to flip it. And I'm going to call it 2/1, which is 2. Okay, so I'm going to multiply all of these values by 2. And anytime it's not a fraction, you can make it a fraction by putting it over 1. So 0 times 2 is 0. Pi over 2 times 2. Pi times 2 is 2 pi, and 2 times 1 is 2. And those 2's will cancel out, and just leave me with a pi in that spot. So I'm going to change that to a pi. Pi times 2 is 2 pi, so if you're observant, you can figure out what the next value is without looking. It's 0, 1 pi, 2 pi, the next one's going to be 3 pi, and the next one's going to be 4 pi. But if that doesn't make sense to you, then do the math. 3 times 2 is 6 pi over 2. Well, 6 divided by 2 is 3, so that's 3 pi. And 2 times 2 is 4 pi. So what once took me from 0 to 2 pi to finish, now takes me from 0 to 4 pi to finish. So the length of the graph is now 4 pi. So the period is 4 pi. What used to have a max height of 1 now has a max height of 1/4. So the amplitude is 1/4. So that was A, amplitude, and B, period. C and D, eventually we'll learn, do other things, okay? They move the graph left and right and up and down, which in my opinion is easier to do. I think this one's the hardest, the period change. So tomorrow we'll do left, right. The C value is the left, right, okay? If you want more practice, page 3 has more practice. I have it as practice/homework. I'm not gonna go around and check it, right? You can do it if you want. The key is on Canvas. That's completely optional. When you come in tomorrow, we'll do a warm-up. That's practice of what we did today, and then we'll do new stuff, and we'll continue that pattern. Technically, you'll be done with the content on Thursday. There's only an A, B, C, and D. Then the way that it falls is kind of weird because we have a long weekend, and I'm not going to quiz you after a long weekend. So we'll actually end up having 2 review days before you have a quiz. And I was able to pull you all in for a bonus block too, so technically you'll have like 3 review days before the quiz, alright? So I think the quiz is the next Wednesday, a week from tomorrow. but we're technically done the content this Thursday.
This is the last thing we're learning.
This is the last unit, yep.